All right, welcome. So today we are going to tackle a core algebra skill, solving two-step equations. But look, we're not doing this the boring old textbook way. Oh no, we are going to frame this whole thing as a high-stakes adventure. I want you to think about it this way. What if our variable x wasn't just some letter on a page? What if x was our hero trapped inside a mathematical puzzle? And our job? Our job is to rescue it. That's the game plan today. Algebra as a rescue operation. Okay, first up, the variable's mission. See, every good mission needs a crystal clear objective. Before we do anything, we have to know exactly what we're trying to achieve to get our variable out of there.
Now, some missions are simple. A one-step equation, something like 3x equals 12, that's a quick extraction. Easy in, easy out. But today, we're on a two-step mission, something more like 3x plus 4 equals 19. This one needs a bit more strategy, because there are two different obstacles we got to clear to save our hero, x.
So here's the bottom line, the absolute number one goal of this entire operation. Isolate the variable. That means getting x completely, totally alone on one side of that equal sign. All its guards, all its barriers, they have got to go. All right, section 2, the reverse code, SADMEP. To pull off a rescue this precise, we need a secret strategy. And here's the best part. You already know half of the code. Seriously, you have the key to dismantle this thing already. Remember PEMDAS? Come on, you know it. Parentheses, exponents, multiplication, division, addition, subtraction. It's the order of operations you use to build things up in math. It's actually how our hero x got trapped in this equation in the first place. And here it is. This is the big aha moment. If PEMDAS is how the trap was set, then to solve it, to get x out, we just have to undo every single step. In reverse. It's like walking backward out of a maze following your own footsteps. And that gives us our secret code, SADMEP. It's PEMDAS spelled backward. That's it. This is our strategy guide for the rescue. We'll handle subtraction and addition first, then we'll deal with division and multiplication. This is the order that clears the path. So our whole two-step plan is actually super simple. First, we deal with any numbers being added or subtracted. You can think of these as the guards standing kind of far away from our hero. Then we handle the numbers being multiplied or divided. That's the guard standing right next to x. Okay, enough planning. It's go time. Section 3, executing the rescue. Let's get our hands dirty and put this SADMEP strategy into action on a real mission. All right, team, here's the briefing. The mission is 2x minus 5 equals 15. We can see our hero, x, is blocked by two obstacles. It's being multiplied by that 2, and there's that pesky minus 5 hanging around. Our job is to clear them both. According to our SADMEP plan, we handle subtraction or addition first. So that minus 5, that's our first target. It's kind of the loose number just hanging out there. To get rid of a minus 5, we do the exact opposite. We add 5. And here's the golden rule. To keep everything balanced, whatever you do to one side, you must do to the other. And just like that, look what happens. The minus 5 and plus 5 on the left, they cancel each other out. Gone. That just leaves 2x. And on the right, 15 plus 5 becomes 20. We've successfully cleared the first obstacle. The field is much simpler now, right? 2x equals 20. Now for the final step. X is still not alone. It's being guarded by that 2. It's being multiplied by 2. Well, to undo multiplication, we use its total opposite, division. We have to divide x away from its guard. Let's execute that final move. We'll divide the left side by 2. That'll break the guard's hold on x. And of course, to keep that scale perfectly balanced, we have to do the exact same thing to the right side. And there it is. 2 divided by 2 is 1, leaving us with just x, all by itself. And 20 divided by 2 is 10. Boom! Mission accomplished. Our hero variable x is free, and we know its value is 10. But hold on, we're not done yet. Section 4, confirming success. Like any good agent, we have to debrief. We think we have the answer, but in math, we can be 100% certain our intel is correct. It's time to confirm our success. So how can we be absolutely positively sure that x is 10? What's the proof? This next step is honestly one of the most powerful and satisfying parts of solving equations. It's simple. We check our work. We take the solution we found, our value of 10, and we plug it right back into the original mission briefing. 2x minus 5 equals 15. Let's run the numbers. 2 times 10 is 20, and 20 minus 5 is 15. We're left with the statement 15 equals 15. That is a perfectly true statement. It works. The equation is balanced. Mission confirmed as a definitive success.
Okay, let's try looking at this from a totally different angle. Section 5, seeing the math. For all you visual learners out there, sometimes actually seeing the problem can make everything just click. Time for a little visual recon.
We can actually model our equation using simple objects. So let's imagine that every x is a cup. We don't know what's inside it yet, right? It's a mystery. And every regular number is just a simple little counter or chip. So our equation 2x minus 5 equals 15 would look like this. 2 mystery cups and 5 negative counters on one side of a scale, balanced by 15 positive counters on the other. The goal is exactly the same. Get the cups by themselves. You'd first add 5 positive counters to both sides to cancel out the negatives. That leaves you with 2 cups balancing 20 counters. And from there, it's pretty easy to see that each cup must be holding 10 counters. See? It's the same logic, just made visible. So there you have it, the secret code, the rescue mission, and the visual proof. You now have the logical tools to solve any two-step equation out there. So the final question is this: where else do you see this logic? What kind of real-world problems, from figuring out a budget to planning a trip, require you to undo 2 steps to find some unknown value? Think about it. Thanks for joining the mission.